Okay, just a quick video on multiplying monomials. There are a bunch of rules that have really cool names and they look weird, but they're really easy to apply. So let's try a little bit of that, please. Here's product of powers, and it suggests to us that a to the mth power times a to the nth power is equal to a to the m plus n power, which sounds, I don't know, weird, I guess. But if you think about this a little bit, you see that what it's saying is if we have 3 to the 4th power times 3 to the 2nd power, we'd get 3 to the 4 plus 2 power, 3 to the 6th power. So here are some really important ideas here. One, caution. These factors here, this one here, this base and this base must be the same number. Second thing that's crucially important is these are rules of multiplying, not rules of addition. So we do have multiplication here, don't we? 3 is the same as 3, so we can add this. Look at why this is true. And I think you'll get it, but you might be a little bit less impressed. So here, let's take this one first. 3 to the 4th power means 3 times 3 times 3 times 3, doesn't it? That's 3 to the 4th. Look at this for a second. This multiplication sign right here is this multiplication sign here. And then we have this 3 to the 2nd power, which just means 3 times 3, doesn't it? And let's see if this isn't true. We have a base of 3, right? They all have the same base of 3, so we're going to get 3. To what power? Well, 3 squared, 3 times 3 is 3 to the 2nd power, so 3 to the 1st, 2nd, 3rd, 4th, 5th, 6th power. 3 to the 6th power. So while the rule looks kind of cool, and it looks like maybe, wow, how does this make sense? It actually does make sense. It's nowhere near, in my opinion, as difficult as it looks. So there's that rule. Let's try one of these together. What I'd like you to do is write down the problem, stop the video, see if you can solve it, and then come back and see how it works out, okay? So let's do, I don't know, 2 to the 2nd power maybe times 2 to the 3rd power, okay? Stop the video, try the problem, come back, and we'll work this out together, okay? See you in a second. All right, welcome back. Hopefully you did pause the video. So first thing we did, right, was we checked a couple things. We went to see, are the bases the same? And this has a base of 2, and this has a base of 2, doesn't it? We do have multiplication. There's our multiplication sign. So what we're going to do is we're going to take this, and we're going to use this rule, product of powers. So we're going to say that this is going to be equal to 2 to the 2 plus 3 power, otherwise known as 2, whoops, hello, sorry, 2 to the 5th power. Again, we can prove this out because 2 squared is 2 times 2. This multiplication sign right here is this multiplication sign. Then we have 2 to the 3rd power, 2 times 2 times 2, right? Is equal to, right, the base is 2, so 2 to what power? 2 to the 1st, 2nd, 3rd, 4th, 5th power. Works out fine, doesn't it? Now you're asking, well, why would I bother? When is this a big deal? I don't know. What if you had some crazy problem like, I don't know, like this. You had 2 to the 17th power times 2 to the 3rd power. Well, do you really want to write 17 factors of 2 times 3 factors of 2? Or would you rather just say 2 to what power? Right, to the 20th power, right? Because we're going to use this product of powers rules. Okay? All right, let's try something a little bit different here. Okay? There's a second rule that I'd like to talk about, and it really makes a lot of sense, but people get really, really confused about it. And the name of the title of the rule is actually power of a power rule. So it's called power of a power. So let's call this rule number 2, if you don't mind. Rule number 2. And it's power of a power. Power of a power. And power of a power suggests to us this. It says that if we have a to the mth power, and the whole thing outside parentheses raised to the nth power, then what we really have is a to the m times n power. So a to the m times n power, where this m is this m and this n is this n. See, we only see the base one time, but we have this little, looks kind of confusing here. But this makes really good sense too if you think about it. You know, I've heard a lot of people they get really, really confused about this, but I think that if you think about it for a second, let's take an example here. So take example 1 here. Let's see, we have 5. Let's see, we have 5 squared. Well, 5 squared means 5 times 5, doesn't it? But look at this. Isn't this true, that 5 to the 1st power right? 5 to the first power is the same as 5 to the first power squared, isn't it? Which would be, in the weirdest way, would be 5 to the 1 times 2 power, wouldn't it? So just as a way to demonstrate that. So here we have the base here is 5 to the first power. So 5 to the first power. And look, we can actually go back and use the first rule that we talked about, right? We can go back and use the product of powers rule here, and we can just say this is, right, 5 to the 1 plus 1 power. But look at this for a second. What if we did this, just to show you why this rule was necessary? What if we had 5 squared, and we raise that to the, I don't know, I want to raise that to the third power. In this case, look, we had 5 to the first power was our factor, and we had 2 factors of that, didn't we? Now, what's our factor? Right? Our factor now is this piece right here, isn't it? So in this case, our factor is 5 to the second power. And how many 5 to the second powers do we have? We have 3 factors of 5 to the second power. So we have 5 to the second times 5 to the second times 5 to the second. So if we wanted to, we could use rule 1 and we could just count 2 plus 2 plus 2 is 5 to the sixth, isn't it? So what this rule here, power of powers, does, it provides us a little way to simplify this. So what we're going to get is 5 to the 2 times 3 power, right? Which of course, lo and behold, gives us 5 to the 6th power. And maybe you're noticing right now, saying, how come he isn't getting a number? When we're using these rules, I'm suggesting to you that unless you have a calculator, I mean, what is 5 to the 6th power? It's a pretty big number, because 5 to the second power is 25. So 5 to the third is 25 times 5 is 125. So I'm not looking for a number here. I'm just looking for this to be simplified into a form like this, okay? All right, let's try something that's a little bit, let's try this. What if we had this, just as our last really quick example of these rules? Example 2. Example 2 of this. What if we had, I don't know, we had x squared. How about, let's do this one. I like this problem. What if we had this? What if we had 2 x squared to the second power? Now what we have to realize is this. Now I want you to stop the video and write this down. This is crucial. That exponents are distributive. I'm going to say it again. Exponents are distributive over multiplication. So what we're going to do is this. We're going to do, right, this is 2 to the first power, isn't it? So we're going to do this. We're going to do it here. I'm going to have it here. And it's going to look like this. It's going to look like 2 to the 1 times 2. Let's color code this a little bit. On 2. 1 times 2. Right? This one right here is this one right here. This 2 is this exponent of 2 times 2. Remember, this is 2 times x squared. So times, our x squared was in purple, lavender, whatever that is, squared, times what? Come on, times, good, times 2. And isn't it true when we simplify all of this out, we would get 2 squared x to the, what? Good, x to the 4th. We can simplify this out a little bit because 2 squared is a number, isn't it? And 2 squared is how much? Exactly, 2 squared is 4, so we get 4x to the 4th power. I'm not saying this is easy, but we can definitely do this. Take good notes, and I'm looking forward to your comments. We're still taping.